Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question belongs to paper 9709/41 for the session May June 24. And we are solving now question number 4. The question says a car of mass 1700 kg is pulling a trailer of mass 300 kg along a straight horizontal road. The car and the trailer are connected by a light inextensible cable which is parallel to the road. There are constant resistances to motion of 400 Newton on the car and 150 Newton on the trailer. The power of the car's engine is 14,000 watt. Find the acceleration of the car and the tension in the cable when the speed is 20 meter per second. So first of all, what we do for any solution, we should find out the concept to be applied. So we are going to apply the concept of the motion law of Newton. And in terms of motion law of Newton, this is actually one of the simplest solutions. First of all, let me sketch the scenario. Suppose this one is the car, this one is car which is moving onward horizontally, moving onward, and then it is pulling a trailer. Suppose this is the trailer, okay, and in between them there is tension working, that means this inextensible cable. So already we have decided that we are going to apply the concept of the motion law of Newton. Well, so for car, first of all, we are taking, as there are two different objects or vehicles moving onward with the same speed, same acceleration. So one after the other, we will have to solve the question. So first of all, car, for car, okay, for car, and the concept is actually driving force minus resistance force equal to mass into acceleration. Well, so driving force, let us see the driving force. For the driving force, we know a formula of driving force is P over B, means power over velocity, minus resistance force of the car. Resistance force of the car is given as 400 Newton, minus 400 Newton. Now for the car, look at this, there is one more resistance force, negative force. That means this cable is the tension. This tension is causing resistance to the car. So the tension in the cable is also a resistance force in terms of car. And the right side, mass into acceleration. Mass of the car is 1700 into acceleration. Then power is already given. How much is the power of the car? Power is 1400 watt. So 1400 watt over velocity. Velocity has also been given. It's 20. Minus 400 minus tension is equal to 1700 into acceleration. So if we isolate A, it is going to be, they have told us to find acceleration, so we are going to make T as subject. Let's divide 1400 by 20. It is going to be 70 minus, not 70, it is not 1400, it's actually 14,000. Sorry, there will be one more zero. 14,000. If we divide 14,000 by 20, it is going to be 1700 minus 400. So let it be written 300. Okay, it is going to be 300. Yes, putting one more zero. So 700 minus 400 is actually 300. 300 minus 1700 A is equal to T. we may leave this as equation number 1. So we have completed one equation, and we'll have to form simultaneous equations because simultaneously there are two quantities missing. Let's form the another equation using the trailer. So for trailer, can we write just below this? Yes, we can. So for trailer, for, let me change the ink, for trailer, for trailer, for trailer, same concept we should apply. For trailer, driving force, driving force minus resistance force is equal to mass into acceleration, and driving force of the trailer is nothing but the tension over here. Look at this, only this cable is having the driving force in terms of the trailer, because trailer is being pulled forward by the tension. So tension is the driving, only driving force, tension minus, there is only one resistance motion which is constant as it is given in the question, which was 150 Newton. So let us write minus 150 Newton, 150 Newton, and there is no more resistance forces, equal to mass of the trailer is, mass of the trailer is given 300 kg. So 300 A is going to be 300 A, 300 A. Well, or if we isolate t to form simultaneous equation, it is going to be 300 a minus 150. Let it be equation number 2. Now let us solve both the equations simultaneously. If we solve the equation simultaneously, we will get, the first equation was, what was the first equation? 300 minus, this is the first equation. First equation 300 minus 1700 a, 300, we can write here that from equation, from from equation 1 and 2, 1 and 2, and look at this, in both equation 1 and 2, the left side is actually nothing but t, I mean tension. That means one of the sides is tension, so definitely the other side must be equal. We can write here, okay, so first equation was t equal to 300 minus 1700 a, 300 minus 1700 a, and the other equation was t equal to what? 300 a minus 150, 300 a minus 150, 300 a minus 150. If we simplify, 300 plus, this is 300 minus 1700 a actually. So if we add up all of the a's, 1700 a plus 300 a, so it is going to be negative 2000 a, 2000 a, equal to, if we add up this 300 and 150, it is going to be negative 450. Okay, wait, we might make a mistake somewhere. Let us check whether both the equations have been formed correctly or not here. Look at this, negative 150 will be actually positive 150 because it has transposed its position. So it is going to be plus 150, plus 150. So plus 150 minus 300, it is actually 150, not 350, it is 150. Okay, 150. Hence our acceleration is going to be, if from both sides, if we dissolve the zeros, it is 15 over 200. Hence acceleration is going to be, acceleration is going to be, let me use my calculator, 15 over 200 is equal to 0.074 something, so it's 0.075 meter per second square if we round up the answer. So this is our acceleration, and the second part of the question was The question told to find even the tension also. So tension is equal to, already we have formed the equation. Tension is this one. We can use equation number 1. T is equal to 300 minus, so T equal to, T equal to what? T equal to, tension is equal to 300 A, 300 into acceleration is 0.075 plus 150. If we add up these two quantities, then tension is going to be 300 into 0.75 plus 150 equal to 172. 172.5 Newton. So these two are our result. Okay. So tension is 172.5 Newton, whereas our acceleration was this. I think you have understood this, one of the simplest solutions. But here you may raise one question, which is, always we use the weight in case of the application of the concept of the motion law of Newton. So here weight is actually, if you talk about the weight is mg. Let me change the ink. Weight is mg cos theta. Now look at this, as this is horizontal, look at this, this is our horizontal line. Okay, so for horizontal line it will be actually 0, angle will be 0. If angle is 0, it will be cos 0, and m cos 0 is mg cos 0. Cos 0 means 1. So sorry, cos 90. Sorry, I made a mistake. It will be cos 90 because it is acting vertically downward. So the angle is actually 90. Okay, angle is 90. Angle is here 90. Okay, if angle is 90, then it will be cos 90. Cos 90 is equal to 1. Cos 90 is equal to actually 1. It will be cos 90. So cos 90 is nothing but 1, equal to 1. That's why if we multiply by 1, if weight is multiplied by 1, ultimately it will be actually the same. Sorry, cos 90 is 0. I'm making mistake. Cos 90 is 0. If we add up or subtract 0, then it doesn't make any change to the quantities. That's why actually weight has been ignored. So one thing is being learned from this solution. If the plane is horizontal or parallel to the horizontal, in that case weight, that means or force caused by weight is actually 0, because it moves on a 90-degree angle, and cos 90 degrees is equal to 0. That's why it has been ignored. But usually weight is not ignored in case of the concept of the motion law of Newton. I think all of you have understood well. So thank you for watching the video. Fi amanillah.